Okay, the next we're looking at x equal y squared over 2. Well, that's something that looks like this. And then I'm cutting that off at x equals 0 and at y equal 4. So this region. So if I enlarge this a bit, if I go for y equal 4 and x equal, let's say it looks something like this, right? X equals 0 and y equal 4. Let's say the region looks just like this. And in this case, I'm rotating this above the y-axis. Wouldn't this create an image just like it? And it'll really occupy all of the space, but keep in mind how this works. You're going to run this by running to that original x equal y squared over 2, and we're going to pick our rectangle perpendicular to the axis of rotation. And do you see that it's going to create the following disk, in which the radius is right there. The radius is this distance. And since I'm picking this at delta y, everything's in terms of y. This radius is y squared over 2. And I'm trying to figure out the area of that. And that's pretty much how everything works in this section. So volume is going to be the integral. In this case, I picked it to be a delta y. Y equals 0 to y equal 4. And the area of a circle is pi times the radius squared. The radius is y squared over 2. And if I say set up, do not solve, that's it. If I say solve, you can solve that. Distribute the 2 in and go from there. The next problem, y equals 6 minus x. Again, it's a good idea to really kind of glance at this and figure out how that works. Upside down parabola. Y equal 2. Okay, it seems this much. So if I take y equals 6, 1, 2, 3, 4, 5, 6, it opens down, it's going to hit at radical 6, which is 2 point some. So, but I'm going to cut that off at y equal 2. At y equal 2, there's going to be a line. So instead of this continuing and crossing that x-axis, it's going to stop right there. We're talking about this region. This is the pre-image, original. This is y equals 6 minus x squared. Well, if I rotate this about the x-axis 2 units below, you're going to mimic the line y equal 2. And 3, 4, 5, 6, you're going to create an image that looks just like this. If I go to the original, always the original, and if I draw my perpendicular to the axis of rotation vertical line, which means at the x, okay, do we agree that it's going to look like this, but it's hollow on the inside? So it's going to look something like this, hollow, and then the outer is going to be the purple, which is, and the region that we discussed is actually this part. And there is no shortcut to this. I'm going to show you, and I'm going to give you a warning as well. Well, if I look at the purple, this radius is actually all of that distance. So that would be, volume will be the integral. We're doing this with respect to x because we picked it vertical. And it's going to be pi times the first, isn't the first radius 6 minus x squared? Minus, and do we agree that this inner radius, this hollow part, is actually top minus bottom again? That would be what? Pi times, isn't that only 2 units? Integrating from x equal what to x equal what? If I take this and I replace y by it, I'll get 2 to equal 6 minus x squared to be 4. So x will equal plus or minus 2, from negative 2 to positive 2. And that would be my answer. Alright? And if I look at the next problem, x equal y to the fourth. So if I color that green, x equal y to the fourth looks like this. And x equal 2 minus y squared. So the region in question is actually this region. I'm gonna rotate this about the y-axis. So let's see, this green part will get a piece like it right there. And the purple part will actually come out too and look like this. That would be the image of that. So if I go for the pre-image, always the pre-image, and if I draw my rectangle, in this case sideways, perpendicular to the axis of rotation, do we agree that the outer circle will look like that? And the radius of that obviously is the distance from the origin, so right minus left. Right, let me think really quick. Since the axis of rotation is the y, so this distance is actually this distance, and that would be the 2 minus y squared. So far, volume will be the integral with respect to y. Well, let's see. Replace x by that. That looking at y to the fourth equal 2 minus y squared. Y to the fourth minus plus y squared minus 2 equal to 0. And this factors y squared plus 2y squared minus 1. Y squared equaling negative 2 never happens, so y will equal plus or minus 1. So this is from negative 1 to 1. And if I look at that, I notice I'm going to take the area of that, that's pi times 2 minus y squared, minus, if I look at this piece, so this is what's known as the washer, because it looks like a washer, not a disc. It's hollow on the inside. Isn't this distance right there? And that's right minus left. That will be pi times right will be what? The equation for the green, y to the fourth. Left will be 0. Doesn't make sense to put 0. I forgot the square. So the warning is, do not try to mix the radius of the first and the second together. There's no shortcut to this. So don't say, oh, well, it's going to be this radius minus this radius. No, it's going to be this whole area minus the inner area. That's the way to go. All right. Next problem, number 14. I'd like to look at y equal the sine of x. Well, sine of x, it starts at the origin. Let me shift this a bit to the left. And it runs up, let's say, to 1 and down to 0. So it runs like this. Versus cosine. Cosine starts on the amplitude. Assume that's a 1 and it's going to run down. And I'm only interested in this between 0 and pi over 4. I know at pi over 4 that's that point because that's where they're both equal. So we're talking about this region. Let me make sure. If I glance at this and I want, yeah, that's the way it works. And if I rotate this about the line y equal negative 1, well, the blue is going to look like that, and the green, oops, I got the colors backwards, forgive me. The green will look like this, and the blue would start and come down, and the image of that is right there. Now, if I picked my rectangle perpendicular to the axis of rotation, the outer is the blue. The outer limit is actually the blue. Do we see that? Showing that just a bit, and there it is. So the outer of that is going to be that right there. And how would I find this radius? Radius is, this is the center. Isn't that this distance? Top minus bottom. Top is the cosine of x minus the bottom is a negative 1. So this distance is actually pi plus cosine of x plus 1. So volume is going to be the integral, and I'm going to run from 0 to pi over 4 with respect to x, and it's going to be pi times, for the first area, cosine of x minus a negative 1 is plus 1. Minus, if I look at the bottom part is really that right there. And if I draw the circle, well, it's a washer because the inside is hollow. And that region that I just highlighted actually is that region. So the way it works, I'll find the whole circle and subtract the inner part. Until you're really comfortable with this, I would suggest you make a shortcut. So what is this distance? Isn't this distance really wouldn't that be really this distance? Top minus bottom. And the top is actually the sine of x minus the bottom is a negative 1. So that would be pi times the sine of x plus 1. Now, I keep on forgetting to square. That's a big problem. Be careful with that. So you could say it is going to be pi times the integral and take the bigger radius squared minus the smaller radius squared if you wish. Just do not ever do this. Subtract both of those radii and square them. That's never allowed. And if you're not comfortable with it, don't do it. So if you're not comfortable with the shortcut, that part, stick with this. Okay, how about this problem? Y equal x squared. So y equal x squared is a parabola opening upwards, something like this. X equal y squared. So we see what they're talking about. They're talking about this part. Y equal x squared. I'm going to enlarge that a bit. And x equal y squared. There we go. We're talking about this region. Now I should label this. And I'm going to rotate this about the line x equal negative 1. So, wouldn't this green, okay, wouldn't the black move a unit apart and create an identical copy, and the green identical copy, and that's where the image is? And now I'm going to pick my rectangles perpendicular to the axis of rotation. Do you agree that the outer rim is the black? Do you agree that when I look at this, I see the outer is the black. The black I'm going to take right? And remember, before I begin and mess things up and try to come back and fix them, volume from, let's see, if I picked it this way, then that's a delta y. That is y equals 0. And if I replace x by that, I'll get y to equal y squared squared, or y equal y to the fourth, y to the fourth minus y equal to 0, y into y cubed minus 1 equal to 0. Y would be a 0 or a 1. Got it. This first distance is the right. The right, I really need to solve that equation for x. X equal plus or minus radical y, but in this case, x is positive. Negative would be the left half of the parabola. So, right would be, this piece is really square root of y minus a negative 1. Okay, I'll get it right. Just give me minus a negative 1. That's the radius. So pi times that squared minus, and the hollow part is this part. The green is x equal y squared minus a negative 1 squared. There it is.